Alright, WHS, I'm back, and we're going to talk about sequences again here. I just talked about them when they're an arithmetic sequence, when there's a constant difference term by term down the line, like a set of train cars. Today I'm going to talk about something very similar, I call a geometric sequence. The only difference you're going to find between an arithmetic and a geometric is how you proceed down the line. Arithmetically, we're constantly adding or subtracting. Geometrically, what you're going to actually look for is something that you're multiplying by to go down the line. Okay, otherwise it's the exact same lesson. So here I have a sequence here, and I guess before I get to that, a geometric sequence exists where each term is gotten by multiplying the previous term by a constant of multiplication, or what's called a ratio. Okay, and it's consistent, constant all the way down the line. You're going to have a first term, and you're going to say what you're multiplying by to get to where you want to go. So here I've got a sequence. It's 5, 10, 20, 40. You're not adding or subtracting by a constant, okay? So this is a deal where we're multiplying, and I would assume you can see you're multiplying by 2. So the next term would be 80, 160. And if you wanted to get a term, we again would rely on the previous term to do that, okay? So it's just like arithmetic sequences, except we are using a multiplier onto the previous term to get to the next term every time you use a constant of multiplication to get to the next term. So here is kind of your model. You're going to state the first term. You're going to say to get to a term, any old term, you're going to take the previous term and multiply it by some ratio. You don't have to remember this all this stuff. What you have to remember is there's a start, and then what you're doing to go term by term and identifying that in a formula. Okay? So that is the way that's going to look. So let's see if we could dive right in here and start writing some geometric sequence formulas. So here I've got a sequence, 4, 12, 36, 144, getting pretty big pretty fast. And in fact, we're multiplying by 3s. That is our constant ratio as we go term by term. So we would say, okay, any sequence has got to have the starting term. So G1 is 4. If you want to find your way, now I'll call it Gn because it's a geometric sequence. That's not a big deal. That could be X, that could be T. It doesn't matter what it is. It's just saying I want some term down the line. So I'm going to take the previous, which is always denoted 1 less index. So G sub n minus 1 is 1 before Gn, and I'm just timesing it by 3. That's it. Okay? I can't even make it hard, I don't think. All right, now watch this, because the next one, if you look at it, you probably wait a second, Kohler. You're supposed to be multiplying. And it's clear here that what are we doing? Well, we're dividing by 2. Now, they're not going to say the ratio is a division problem. It's going to be written as multiplication. So I would say to you, what is 20 compared to 40? What could you multiply 40 by to get to 20? And in fact, the second term is exactly half of the first term. Kids, we talked about it in a previous video. 1, when you multiply by 1, you get back yourself. You multiply by bigger than 1, it grows. You multiply by smaller than 1, it shrinks. So you can be multiplying and getting smaller. Okay, it's a misnomer to say multiplication always makes you bigger. Only if you're multiplying by bigger than 1. So this is a geometric sequence just like this is, except we're getting smaller because our ratio is less than 1. So G1 is 40. Some term down the line, we're taking the previous, and we're simply multiplying it by a half. And there we go. Okay, now this third one's a little bit weird. We're toggling from positive to negative. What kind of a multiplier would we have to be using to change signs like that? I'm hoping you would say a negative would get the job done. So in fact, you're multiplying here, if you look at it, by -2. Times it by -2, times it by -2. So our sequence G1 is 3. The nth term is gotten by taking -2 times the previous term. Okay? You have to lay down the first term and how you get to a term using the previous term. And that's how all sequence formulas work that you will see on your MCA state exam. Alright, so there we go. Now again, I could give you the sequence formula and ask you give me a set of numbers for this sequence, write the first 4 terms. Okay? So this is what I kind of call turning math into English. Okay? Which normally it's the other way around. We turn English into math on word problems. There aren't any words here. This is mathematical notation. And turning math to English, I'd say the first term of my sequence is 10. To get a term down the line, take the previous and multiply by 2. Take the previous and multiply by 2. Okay, 10 times 2, 20. Take the previous and multiply by 2. Okay, 40. Take the previous and multiply by 2. Okay, 80. Does that make sense? I hope that makes sense. All right, I have a geometric sequence though. First term is -2, very good. To get any term down the line, take the previous and multiply by -1/2. So I'm going to be changing the sign and cutting this in half. So -2, 1, times that by -1/2, half of that, -1/2 of that, +1/4. And essentially your denominators keep doubling because you're having the previous thing, and the signs toggle. Okay, here's one where I write the code before I write the first. It doesn't matter. PN is 4. Maybe I'm talking about how many potato chips I'm eating. So PN is 4, and it's growing from there. Yes, I like potato chips. So PN is 4. To get a term down the line, take the previous, multiply by 3. So 4, 12, times 3, 36, times 3, 108. Etc., etc., until all the chips are gone. I got to find some other munchie. All right, sequences. We have them, we use them, we formulate them, and there you go. Okay. Don't think you're going to have something like this. I'll show you one here. The river's at a level of 22 feet today. Each day without rain, it drops 1%. After 13 days without rain, what would the level of the river be? You got to say what start. Is it growing or shrinking, and then how long? This is kind of a growth or decay problem. This problem is a decay problem because we're dropping 1%. So we're starting at 22 feet. We're dropping 1%, so you're taking 0.01 from 1. So your ratio would be 0.99, and it's happening 13 times. And you put that in your calculator, you get it. Okay? Jack had an investment, went up an average of 8% a year. He started with $500. What would it be worth after 20 years? This is start. That's G1. It's increasing, so we're tacking on to 1. It's increasing 8%. So 1.08 would be your ratio. And I've got 20 years of growth I'm looking at. Okay? So those will just be some applications. One would be a decay, less than 1, and one is a growth, bigger than 1. And there you have it. Okay? Not going to have to worry about a problem like that. And that is all we need to say about that. So arithmetic and geometric sequences, not that bad. State the first one, state how you get a term from the previous term, and you'll have all you need to know there. All right, I hope that helps. We will see you next time.